Okay, awesome, guys. Our recording is up and running. And just once again, greetings. And I hope you are all doing well. And just as a way of introduction, guys, my name, as you can see on the screen, is SETMind, and I'm going to be taking you through a couple of questions today. So maybe a bit of background about myself is just like you guys, I studied engineering, but I completed. So I studied at VETS and I studied electrical engineering. And as you might all know, our maths is actually more similar than actually different. So I studied a BSc in electrical engineering, obviously completed. I'm currently working as an electrical engineering, as an electrical engineer, and also pursuing my master's. So I like maths, guys, and I hope you all do. Anyway, without wasting any time, I think let's jump into the work which we need to do. So we'll be looking at a few questions, guys, and we'll work over a series of lessons until we get done this paper. And the paper that we are going to be looking at is the 2024 paper. And the paper is very easy. If you look at all the questions combined, it's all about preparedness. If you go in there prepared, you should be able to ace it. And if you look at the first question, it requires us to determine dy dx without, and give the answer without the exponential function. So if you observe carefully, guys, you should be reminded that the kind of function or expression that we are looking at here is an implicit expression. So what an implicit expression means is that we don't have one variable in terms of the other one. So because we have an implicit expression, it means therefore we need to actually do implicit differentiation. Because remember, with explicit functions or explicit expressions, what you have is an expression. Let me remind you. So if you have an explicit, if you have an explicit function, what you guys need to remember is that you have your y equaling a function of x. However, if you look at our expression above here, it is definitely not that. It is rather an implicit expression, which means what is required of us to do here is what we learned during our course, which is called, we need to do implicit differentiation. So what we are going to do, guys, is to differentiate the left-hand side and the right-hand side, and then eventually solve for dy dx. So let's put up our expression. We are given e to the power of x plus y equals xy plus x squared. And remember, guys, whenever I'm doing these solutions, as I'm working on these problems, you are more than welcome to disturb me. Whenever you don't understand, you can just unmute and then ask a clarifying question. I'll be happy to answer you. So whenever you're dealing with implicit differentiation, what you should remember, guys, is that we will go and differentiate the left-hand side and the right-hand side. So let's go ahead and apply our derivatives. So remember, we are deriving with respect to x. So we'll derive our left-hand side, which is that. So I'll copy it, put it here. And what we do on the left, we also should do on the right. So we should do dx on the right-hand side. There's something that I need you guys to pay attention to here. So remember that what we are trying to do here is to differentiate y with respect to x, is to find that answer at the end. But what you need to remember is that y is actually a function of x, and x is just x, okay? So when we differentiate, I need you to have that in mind. So let's look at the left-hand side. Whenever you are differentiating e to the power of something, the answer becomes e, whatever that something is, multiplied by, just keep your mic muted unless you are asking a question, guys. Just check your mic and make sure that it is off unless you are asking a question. So remember, when you're differentiating e to the power of something, the answer becomes e to the power of whatever that thing is multiplied by the derivative of whatever we see on the exponent. This part here, guys, if you remember, it speaks to a rule which we learned when we were doing differentiation, which was the chain rule. And then this will be equal to, let's go to the right-hand side. If you look carefully, we have x, guys, which is a function of x, and y, which is a function of x. So I'm going to treat that as a product. So I'm going to have the x, then differentiate the y, and then plus keep the y constant, and then differentiate the x. Okay, that is what we are going to have, because these here, they behave more like a product, because remember, all depend on x. And we are differentiating with respect to x. Hence, what we are going to do is to use the product rule, which is what I do just below. And then let's add the last term very easily, dx of x squared. So now let's look at the left-hand side. We have e to the x plus y into, when we differentiate x with respect to x, what do we get, guys? Anyone in the meeting? I see a hand from Sakisen. You can go ahead. Just check if you are muted. You can go ahead. I can see your mic is on, but you are not talking.
Can I ask a question? You see on the left hand side.
Yes.
You introduce ln x both sides and derive and integrate?
You mean derive?
Yeah, derive.
Yeah, certainly you can, but it's not going to help you in any way.
Okay.
You see that? Because this is not an explicit function. So we'll get to a problem where maybe using ln or ln will be useful. But for this problem, it's going to make your life a bit difficult. I don't see it helping.
Okay, guys. Since you're saying that, can you please explain for me how did you derive the left hand side? I don't understand. Like, I don't see.
Okay, no problem. So I'll need you to keep your mic on, okay?
Okay.
So there's something which we learned back then when we were doing calculus, which is that when you derive, let's consider e to the power of, let's make a function g of x, okay? Like this. When you derive e to the power of anything, the answer becomes e to the power of that thing that was there. But according to chain rule, we should multiply by the derivative of what is on the power.
Okay.
We should multiply by the derivative of g of x.
Okay. Okay. That means on this, we must keep what we were given and then use the chain rule to integrate our function, which is g at x, ne?
Yes, to differentiate.
Okay, yeah, I understand now.
Point.
Okay,
So awesome. You can now mute. Thanks for that. So guys, let's now go and have a look at the step, and I'll need you guys to participate. Remember, you are not here to watch, and maths is not a spectator sport. So let's get to this, guys. If I derive what is inside the bracket there, what do I get? So I'll put up the e to the x plus y, open bracket. What should I put? When we derive x, what do we get with respect to x? Anyone?
We are gonna get 1.
Yep. It's going to be 1. And then when we derive y, we're
It's
going to
gonna be y prime. Oh, okay.
going to be dy dx. You are on point.
Okay.
And then when we go to the right-hand side, guys, we have x times dy dx. So why we can't give the derivative of? Because we don't know what it is. So our answer is going to be x dy dx. And then plus, we'll have y into times the derivative of x with respect to x, that is 1. Then the last part, derivative of x squared, that is 2x. So what we have now, we can see that when we multiply, we'll have x plus y plus e to the x plus y multiplied by dy dx. And this is equal to x dy dx. And then plus 2x plus y. So remember that, guys, the problem requires us to solve for dy dx. So meaning we should go to what we have found now and make dy dx the subject of the equation. So we need to solve for dy dx. In other words, we need to make it the subject. So if we go and have a look at that, we can take, let me show you how we are going to do that. Let's paste this here. What we are going to do is take this dy dx to the side and then take this part to the other side because it has nothing to do with dy dx, such that we'll end up having e to the x plus y dy dx minus, if you look carefully, x dy dx, and this will be equal to 2x plus y minus e to the x plus y. So if you look at the left-hand side, guys, we can easily factor out dy dx so that we can eventually divide and solve for it. So we'll have x plus y minus x into dy dx equaling what we have, which is 2x plus y minus e to the power of x plus y. So remember, we are looking for dy dx, not dy dx times something. So we are going to go and divide by what we have here. So we are going to go to the next line and then quickly divide. So we need to divide by that e to the x plus y minus x. And what we should do, or what we do on the left, we should always do also on the right-hand side. So even on the right-hand side, I'm going to divide by all of that. And this will result in these cancelling nicely. And let's make some space and have our dy dx the subject and see if we are done. So if you look carefully, guys, you should be able to see that your dy dx will be equal to your 2x plus y minus e to the power of x plus y. All of this divided by e to the x plus y minus x. That is what our exponential function is. So now let's pause here before I jump to the next step and ask, do you guys understand? If you do, please give me a thumbs up. And if you don't, please ask. Okay, that is good. Guys, I'm happy you understand what we did here. So that is our answer. And then the last question, or the last part, we are done finding dy dx. It says, and give the answer without the exponential function. What is your understanding of that, guys? What do they mean by that? Okay, let me show you what they mean, guys. It's very easy, actually. So they don't want the exponential function as part of our answer. And how we are going to deal with that is very simple. Let's take that and put it here, because that part is very important. So if we don't sort it out, the lecturer will not be happy with us and probably take a few marks. So we're done finding our thing. Now we just need to deal with this part here, which is leave your answer without the exponential function. So this is very easy, guys. Look at what we are given as our expression. What are we given? What we are given is that we can take e to the power of x plus 1 and replace it with xy plus x squared. So meaning I can go to dy dx. Wherever I see e to the x plus y, I'm going to replace it with that. So minus e to the x plus y, I'm going to put xy as x squared, and then divided by, wherever I see e to the x plus y, I'm going to replace it with xy plus x squared, and then on the denominator we have minus x. So let's just try and simplify that, of which it's not going to simplify any further. So our answer, guys, is finally this dy dx. And as you can see, there's no exponential function. We'll just have 2x plus y minus xy minus x squared divided by our x squared plus xy minus x. We can leave it like this. I do not see a need for us to further simplify this. Do you guys understand? If you do, give me a thumbs up. And if you don't, please ask a question. What is very important is we had to leave our answer without an exponential function. Right. Awesome, guys. Let's go and deal with the next question. So the next question requires us to show that our hyperbolic tan of ln of x is equal to that. So what I need you to remember for this question is your hyperbolic functions. Because that is actually what we need to get this done. So I'll remind you of two of them and you'll tell me about the third one. So if you guys remember, hyperbolic sine of, let's say, x, or let's use theta, is the same as e to the power of theta minus e to the power of negative theta divided by 2. This is hyperbolic sine. And then hyperbolic cosine of theta is the same as e to the power of theta plus e to the negative theta divided by 2. And if you observe carefully here, guys, you should be able to see that whenever we are looking for hyperbolic tan of theta, we will do hyperbolic sine of theta divided by hyperbolic cosine of theta, of which, if you quickly divide these two, it will be obvious what your answer becomes. So that is hyperbolic sine divided by, let's fetch hyperbolic cosine. Paste here. Let me create some space here, guys. That. So if you look carefully, the 2 and the 2 will cancel, which means our hyperbolic tan will actually be e to the theta minus e to the minus theta divided by e to the theta plus e to the minus theta. Do you guys understand? But that is our hyperbolic tan. So hyperbolic tan theta is e to the theta minus e to the minus theta divided by e to the theta plus e to the minus theta. Why is this relevant? This is relevant because you need to remember one more thing for you to ace this problem here. And here's what I want to remind you. What I want you to remember, guys, is that whenever we have e to the ln of anything, let's call it p, the answer becomes p. Isn't it beautiful? So when you have e to the ln of something, the answer becomes whatever the thing is. So it means if we have e to the ln of uj, the answer becomes uj. So let's go and sub this now that we know it. So now that you know your hyperbolic tan, it means if they say they are looking for hyperbolic tan of ln of x, they are looking for e to the ln of x because this guy becomes more like our beta. And then minus, if you look at our equation, e to the minus ln of x divided by e to the ln of x plus e to the minus ln of x. Are you guys still following? A thumbs up if you do, a question if you don't. Right. I can see a couple of thumbs ups. So let's go and ace this, guys. So we can use this law, but now there's a problem. With the others, there's a negative here, but our law says e to the ln of p. It doesn't say e to the ln of minus p. So it means we need to deal with that negative there. How are we going to deal with the negative? It's very easy. E to the ln of x minus, I'll put the bracket, e to the ln of x, then we put the minus 1 outside. Because we understand exponential laws, we know that that is allowed. Then divided by e to the ln of x plus e to the ln of x, then we put in a minus 1 there. So, and guess what? What is e to the ln of x, guys? Now that you know the notes that I made for you here, and remember, what is e to the ln of x? Anyone, guys? What is our e to the ln of x?
It's going to be x.
On point. So it is going to be x. And then if you look at the other part, inside there, e to the ln of x is going to be x, but to the power of minus 1 divided by, below we'll have e plus x to the power of minus 1. And now we can go ahead, guys, and try and solve this. So we'll have x minus x to the minus 1. By now, you guys should know that it's 1 over x divided by x plus 1 over x. But we can see that our answer doesn't have any 1 over x here. So how can we remove that x which is appearing now here? We can remove it by multiplying the denominator by x and also by multiplying the numerator by x. And when we do so, you will see that our answer will end up being x squared minus 1 divided by x squared plus 1. And that becomes what our tan or hyperbolic tan of ln of x is. So that, guys, is our answer. You guys understand? Give me a thumbs up if you do, and the equation if you don't. Very nice. So the things that I will be writing throughout these sessions as things you should remember are things that they're expecting you to know. So we are done with this question. Very easy. You needed to remember your hyperbolic functions and this identity in the pink box. This is very important. Let's go to the next question. Next, let me see what happened here. Okay, I'm not sure why we have an integral so early, but anyway, let's deal with it, guys. So let's evaluate this integral. We are required to integrate this here, and as you can see, it's a fraction. So we need to remember something that is very important when we see this, something that speaks to partial fractions. That is what I think of immediately. But let's see if we can somehow simplify this. So we have 4x squared minus 3x minus 4. So we'll try and investigate if there's anything that can cancel on the denominator and numerator. Then we have x cubed minus 2x squared plus x. So let's see if we can try and factorize this numerator here. And let's also see if we can try and factorize that denominator. We can, we'll attempt to. If we can't, I can see there's a common factor already, which is x. And the denominator, I can tell it's going to be x minus 1, x minus 1. What about the numerator, guys? Anyone who can see how this will simplify? Okay, let me just maybe give it to you. I think it will be x minus 1 for x. So this will be plus, if I take it that way, let me see. That will be a 4 and then a 1. And then this will be a 4. That will not add up. Yeah, so if you think carefully of how this is going to unfold, do we have anyone who has a suggestion? Okay, let me check what I actually want to check here. So I'm going to put 1 here and see if it is a vector. If it is not, then the approach I'm going to take is use partial fractions. So I'm going to have 4 minus 3 and minus 4, which this is going to be negative 3. So x minus 1 can't be a factor. So here's what we are going to do, guys. We have our denominator as 4x squared minus 3x. Our numerator is that, and our denominator, when you factorize it, you'll get x into x minus 1 and x minus 1. So what I'm going to do is go straight to partial fractions. So our partial fractions, guys, require us to have a over x. So if you do remember, let's take this, and put it here. So when we look for our partial fractions, we'll have a over x plus b over x minus 1, and then plus c over x minus 1 squared. So this is what our partial fraction will look like. Now, what we need to do is to go and figure out what is the value of a, what is the value of b, and what is the value of c. Do we have anyone who remembers how we do that? Anyone, guys? Okay, let me go ahead. So what we are going to do is, if you remember your partial fractions, I'll need you to go and revise that. We will multiply the right-hand side and left-hand side with the common denominator, which is that portion there. So when we do that, you will see that what we will end up having is 4x squared minus 3x minus 4 equaling, we'll have a into, we'll have x minus 1 all squared plus b into x minus 1, and then plus c times x. This is what we are going to have after doing that multiplication. I really urge you to make sure that you do go and revise your partial fractions. So for us to solve for a, you remember, what we can do is to eliminate all the other guys. So how can I do that? If I want to solve, let me see. Yeah, let's start with a. Or maybe let's start with c. C is the easiest. So if I want to solve for C, what I'm going to see is that I can eliminate this bracket by setting x to be 1 and this one x to be 1. So if I set x to be 1, if you look at the left-hand side, I'll have 4 into 1 squared minus 3 into 1 minus 4. And the right-hand side will be a into a. This will be multiplied by 0. Then plus b, b will be multiplied by 0, and then we'll have c. So if you observe carefully, our c will be negative 3. Do you guys understand? So you just sub in x is 1 in the equation, and you will see that the a bracket will have 1 minus 1, so it will be multiplied by 0. The b bracket will also have a 1 minus 1, so it will multiply by 0. So our c is 3. And then now we can go ahead and try and find b. So if you think carefully, maybe let's not find b, let's find a. So if you look at a carefully, if I can set x to be 0, the b will be gone and the c will be gone. So we are going to say, let's set x to be 0. So when you look at the left-hand side, you'll have 0 squared minus 3 times 0, and then minus 4. This will be equal to our a. We'll have 0 minus 1 all squared. Our b will be multiplied by 0, and our c will be multiplied by 0. And the equation that we are referencing, guys, is this equation here. So if you observe carefully, you will see that our a will be negative 4. Okay, because these other parts will be 0. So that will be 0 and that will be 0. So our a is negative 4. Do you guys understand? Thumbs up if you do, a question if you don't. Awesome, guys. Thanks for those thumbs ups. So if you don't understand, please ask. So now we have our a and our c. What we are missing now is our b. And if you think carefully for b now, we can choose any x value. So we can choose any x for b because we already have the other ones. And I'm just going to take a simple x value. I'm going to choose x is 2. So I'm going to have 4, 2 squared minus 3 into 2 minus 4 equals our a we already have, which is minus 4. So it will be 2 minus 1 all squared plus our b is what we are looking for. So let me make that to be clear, that what we are looking for is b. And what we are going to do is to choose x is 2 as an example. Someone else would have done this differently, and I would be happy to show you that. But there's many ways we can go about this problem. So I'm not going to stress on that. So this is a, which is minus 4, and then plus b, which will be multiplied by 2 times 2 minus 1, and then plus c. Our c we obtained as negative 3 multiplied by 2. So let's quickly sort out the left-hand side, guys. What we have is 4 times 2 squared, which is 16. And then 16 minus 6, that becomes 10 minus 4, that becomes 6. And then what we are going to have there is minus 4. Then for the b, we are going to have 2b, and then minus 6. So if you look carefully, this and this, that becomes minus 10. And then transpose it, it becomes positive 10. So we end up having 16 equals 2b. And then now we can divide by the 2 on both sides, such that what we end up getting is b equals 8. Do you guys understand? Right. So here's what I want you to do. If you are confused, I need you to go and revise this section. Because if you are confused here, it means what you are struggling with fundamentally is partial fractions. So now that we have this sorted, guys, we can now go back to our expression. So it means our expression is equal to our a, we have found is negative 4. So we have negative 4 over x. And then our b, we have found is 8. So we have 8 over x minus 1. And then our c we found as -3. So we have -3 over x minus 1 all squared. So remember, this is what we now need to go and integrate. So let's go to the next page and deal with the integration of this part of the expression. Right. So let's go ahead, guys. The integral, one thing I need you to remember, which should be very easy for you to remember, and this is just your basic integration. If you're integrating, let's say b over ax plus c dx, you should remember that your answer will be b ln of ax plus, let me use d here, plus d, and then plus c. But what is very important, by chain rule, you should divide by the a, so that when you derive, you will, undo that effect. So this is just about what you need. And if you look at our problem, you'll see that we'll have -4 ln of x, and then plus 8 ln of x minus 1. And then for the other part, what you guys need to realize is that that other part doesn't need ln. Let me rewrite it for you. So the other part is a 2. So how it can be rewritten is this way. We can rewrite it as x minus 1 to the minus 2 dx. So that when we come here, what we are going to do is add a 1. Sorry, should put in -3, -3, -1. Then I add a 1 there, I get a -1. Then I divide by that -1, then put in a plus c. So which means our answer finally will be what we have here, -4 ln of x, and then plus 8 ln of x minus 1, plus, if you look carefully, we'll have a positive there. So I can write this as 3 over x minus 1 plus c. And the question stands. Do you guys understand? Thumbs up if you do, a question if you don't. Right, good. So let's go to the next page. And you're welcome to give a compliment to my drawing. I'm very good, isn't it? Let's go to the next one. And let's have a look at this question. So for this question, we are given that this is what is happening here. A lot is happening, but it's easy. We need to find dy dx. So I'm going to pause here and ask, what do you guys think we should do here? And this is, let's see, it's a 4 points question. So there's a lot happening, isn't it? So this requires us guys to understand a couple of rules. So I'll say here, important to remember. So there's a couple of things that they require you to remember for this problem. One of them, which I identify, is our product rule. So you need to remember your product rule of differentiation. Secondly, they expect us to remember our chain rule. Thirdly, what they require us to remember is logarithmic differentiation. And number 4, what they might require us to remember, maybe not, but let's put our quotient quotient rule. This quotient seems wrong, but I'll leave it. Yeah, this is about what we might need to get this problem done, guys. So what I'm going to do is to deal with the lot from this part. I am going to use our logarithmic differentiation, essentially introduce the ln, okay? And something else that I need you guys to also recall is this. I need you to recall that ln of A times B is the same as ln of A plus ln of B. And ln of A divided by B is equal to what? Anyone in the meeting? Give it a shot. What is ln of A divided by B? I see a hand from Kaki, so you can go ahead.
It's the ln of A minus the ln of B.
Awesome. It's the ln of A minus the ln of B. Then there's another rule that I need you guys to remember, which is ln of A to the power of B. Anyone who remembers what this is equal to? What is ln of A to the power of B? Yep, you can go ahead, Kakiso.
We must drop the exponent down, so it's going to be B times the ln of A, if I'm not mistaken.
Yep, you are not mistaken. It is going to be B ln of A. So we'll take that, guys, and use it here because it will make our life easy. The reason why I put up logarithmic differentiation is because of this term here. That term of x to the power of tan of x. That is the term that made us to consider this. Remember, when do we use logarithmic differentiation, guys? You use it whenever you have g of x, which is a function of x, to the power of another function of x. That is when we usually introduce the ln and other things. So let's go ahead and introduce our ln. So it means I'm going to start by pulling up my y. So my y is x tan of x and then ln of x divided by our cube root of x to the power of 5 plus 3x plus 1. So I'm going to introduce ln. And what we do on the left, we always do on the right-hand side. So let's copy all of that. Put it up here. Okay, so let's zoom in, guys. So what you will see is that we have the case of A, ln of A divided by B here. So when I look at the right-hand side, and maybe let's put it up for record, I'm going to focus on the right-hand side for some time to just unpack it such that it's easy for you guys to see when I start doing the differentiation. So if you look carefully, we have the numerator, which is ln of x to the power of tan of x, ln of x. But the denominator is there. So I'm going to apply this rule already. This one here. So I'm going to apply it here, where I'm going to minus the denominator. So I'll have ln of minus that denominator is all of this. Is that. And now if you look carefully, I can actually apply a couple of rules here. When I look at my numerator, I can actually separate it and make it a product. So I can have ln of x to the power of tan x, because these are multiplying, plus ln of x. Do you guys see that? And then the other ln, which is minus, will have ln into, we have x to the power of 5 plus 3x plus 1. But this is to the cube root. So that is to the power of 1 over 3. You guys understand what I did here? was just applying these rules. Now I saw that x tan x is multiplied by ln x. So looking at the law, ln AB, I can split it into ln of A plus ln of B. That is what I did. And then cube root, I know it's to the power of 1 over 3. So I'm applying those laws. So when we look at the first part, guys, which is this, I'm going to make it in pink. That first part further simplifies because I have this law now where I can drop the power. So I can have tan x into ln x. And then plus I have that ln of x. I'm very happy. And then now I can drop even the power, which is that 1 over 3. So let's put down that 1 over 3. So it will come out and be negative 1 over 3. And then ln of x to the 5 plus 3x plus 1. Do you guys understand? Thumbs up if you do. Question if you don't. So this one is this one. And this portion is now that one. Right. So now if you observe this, guys, now this feels a bit easier to actually differentiate. Right. Because this is now just equal to ln of y. So this we can easily differentiate now, and our life is no longer as complicated as it appeared to be. Because now all what I need is just product rule, and I no longer need quotient rule, but I will definitely need chain rule. So now this is what we have, guys. And what we are supposed to do now is differentiate the left-hand side and the right-hand side, and we'll do that in the coming page. So we will go and differentiate the left-hand side and the right-hand side. Okay, so let's go to the next page and do that. It's page. And remember, what I'm putting up is something that you should remember, guys. The professors are assuming you know that. So it's very important for you to undergo a lot of revision. So let's see what happens. So d dx will have ln of y equals d dx. Will derive all of this. So I'll put it up in brackets like that. Let's make more space like that. So when we differentiate the left-hand side, what you should know is that differential of ln becomes 1 over whatever you are differentiating, but we are dealing with y. So this will be multiplied by dy dx according to chain rule. And this will be equal to, now we are dealing with product rule here, we'll derive tan. What is the derivative of tan, guys? I think it is sec squared x, isn't it? And then that will multiply ln. And then now we need to go and derive ln, which means we'll have tan x times 1 over x, which is the derivative of ln. Are you guys still following? It's just the product rule in the first part. This part here, when I derive, gives me that portion. You guys following? Right. Now let's go to the ln. When I derive the ln of x, I will get 1 over the ln of x. But remember, by chain rule, you need to derive what is inside here. And when we derive the ln, we get 1 over x. So that becomes 1 over x, which means this portion here, when you derive, you end up getting that. Are you guys following? Chain rule is very important in this approach of ours. Thumbs up if you do understand. So what is very important in these steps is 2 things. There's chain rule and product rule. If you understand the 2, this problem or what I'm doing here should be very easy for you. Missing over 3 and over 3 there. So let's go to the over 3 part. So I have negative 1 over 3 I have a ln. So when we derive ln, we put 1 over whatever that is inside the ln. X to the 5 plus 3x plus 1. Then according to chain rule, we need to multiply by the derivative of what is inside, which is going to be 4x. No, it's going to be 5x to the power of 4, and then plus 3. That is done. Okay? And that speaks to the last part, this one. And that is just chain rule. And remember, guys, for anyone who might have forgotten, if you have y equals f of g of x, when you do dy dx, what chain rule says is derive the outer function, which is f, leave the inner one as it is, then multiply by the derivative of the inner function, g of x. This is what chain rule requires us to do. And I am just applying it to these problems. So let's go and simplify this and see what we get. Paste here. So if you look carefully from what we have above, remember we are trying to find dy dx, so we can multiply both sides by y. So multiply the left-hand side and right-hand side by y. Why are we multiplying by y? We want to remove it here so that we are only left with dy dx. And if you look carefully, our answer will be dy dx will be equal to y multiplying everything that we have found. So let's put it up. So it will be y multiplying everything like that. And we'll go and simplify this. So y will multiply everything here. And that step you shouldn't forget, guys. So we are essentially done with our problem because we just need to put up what y is. And remember, y was given as all of that is given as this. This was what y was given to be. So it means our dy dx, therefore, put up our answer and move on. Below is our answer. And our dy dx will be equal to, I'll open big brackets, or maybe put in the y first outside. So we have y multiplying everything. So we have our y sitting there, and then open the big brackets. We have what we have inside there, which is this first part. Going to take that, paste it here. So that is the first part, and then plus we need the second part, which is what is here. Copy that and paste it here. Make it bigger. And then we need the third part, which you really can't simplify that much. So I'm going to take it as it is. Copy and paste it here. And yeah. That is what we have, guys. And do we have anyone who has a question? Let me put that at the top here. Let's put you there. Do you guys understand what we are doing here? Yes, give me a thumbs up. If no, please ask. Right. That is what your dy dx is supposed to be. And then next we have another question. Sorry. Yeah, okay. So next we have this question, guys, which requires us to use partial differentiation. And we are required to find the partial second derivative of z with respect to x and y. So what is your understanding of this notation, guys? Any one of you, what do you remember when you see this? What does it mean? What does the notation mean? Any volunteers? Go ahead. What do they require us to do there, guys? You can go ahead, Kahiso.
I think we must get our second derivative in terms of y and x.
Yep, that is correct. So what we need to do is find our derivative in terms of x and then find it again in terms of y. So that is what you need to understand. So what that notation means, y then with x, what it means is that we need to go and find the partial derivative with respect to x, and then go and find, this is what it means. So we need to find the partial derivative of z with respect to y, and then find it with respect to x. Okay. And what you should note is that actually this derivative here, partial with y and partial with x, it is exactly the same as the second derivative of z with respect to x and then y. Right. So it's exactly the same thing. So let's go now and look at our z and start. Remember, we start with the inner one, then we'll do the last one at the end, the outer one. So with our z equaling the inverse sign of x over square root of x squared plus y squared. So I need one of you guys to help me to find the partial derivative of z with respect to y. What is it going to become? While I'm on this, let me remind you of something that might be useful for you to remember, of which that is, what is the derivative of the inverse sine of x? Do we have anyone who remembers? What is the derivative of arc sine of x? Should remember this from your differentiation table. What is it, guys?
It's f prime of x divided by the square root of f at x squared plus 1.
Can you please repeat that again?
It's f prime of x divided by the square root of f at x squared plus 1.
Okay, so you've generalized it. We might as well go there. Let's put f of x, call it whatever function. So as you correctly point out, it will be f prime of x divided by the square root of, can you please repeat that?
F at x squared.
So we'll have f of x all squared and then
plus 1.
plus 1. Okay. And what about tan?
Do you mean like the inverse of tan?
Mhm.
Is that a yes, mineral?
With sine, it's not supposed to be a plus there. Remember sine and tan, if I remember, they have minuses. So it is
Sorry.
one.
No, my problems. I give you the hyperbolic one.
Yeah. So we should have this one. Okay. Right. So with this in mind, we should be good to go to our problem, because we are doing the partial of z with respect to y. So we are deriving the inverse of sine, which means at the top, remember we are deriving with respect to y. By chain rule, we should derive with respect to y what is inside, which is x divided by the square root of x squared plus y squared, and then divided by, this speaks to the formula that you gave me, the square root of, we need to do 1 minus whatever that was inside the inverse. So if you look carefully, we had x over the square root of x squared plus y squared all squared. Right. So this is what we need to deal with. So let's have a look at the numerator. So when we derive the numerator, how you should look at it is as follows. That numerator, if you think carefully, it is the same as x into, I'll just say numerator here so that you understand what I did. It is the same as x into x squared plus y squared all to the power of negative a half. Okay, that is what it is equal to. Square root is to the power of negative a half when it's on the denominator. So if we derive that numerator, you will see that we'll get negative 1 over 2, and then times the x that is here, and then x squared plus y squared, and then minus 1, this becomes negative 3 over 2. By chain rule, we should multiply by the partial derivative of what is inside, which is going to end up giving us 2y. Divided by, let's go to our denominator, square root of. On our denominator, you should see that the square will actually cancel, such that we'll end up having 1 minus x squared divided by x squared plus y squared. So this will simplify to be a bit simpler. So let's look at the numerator. Our numerator, the 2's will cancel, such that what we have is just negative xy into x squared plus y squared all to the power of negative 3 over 2. And our denominator, you observe carefully, this will multiply here such that the x squareds will minus, and we will end up having the square root of y squared divided by x squared plus y squared. Okay, this will simplify on the coming page. Okay, let's go and see how this can simplify even more. So if you observe carefully, obviously our square root of y squared will end up giving us x. So we have negative xy into x squared plus y squared to the power of negative 3 over 2 divided by the y there will end up, y squared will end up being a y, and then it will be divided by the square root of that. So we'll have x squared plus y squared all to the power of 1 over 2. So we have nice terms that are cancelling here. The y and the y will cancel. And what will happen, guys, to the other part? We'll multiply the numerator. Do you agree? If you don't, let me just maybe show you. As y squared into the negative 3 over 2. So if you look carefully, we are dividing there by, so this is obviously over 1 now, and we are dividing by 1 over squared plus y squared all to the power of 1 over 2. So when you do the multiplication, you'll end up having these multiplying so that the exponents end up getting up. So it's squared plus y squared, the power of 1 over 2. So our answer, the partial derivative of z with respect to y, will end up being these will add up. So we will end up getting negative 2. Wait, a half plus that will end up giving us negative 1, in fact. So we'll end up having negative x into x squared plus y squared to the negative 1. Do you guys understand? This is nothing deep. It's just you understanding your addition, your multiplication, and so on. Right, this is what we get. Now, all what is left for us to do is to now go and derive this now with respect to x. So now when we go and say the second derivative of z, partial of y, partial of x, now all what I need to do is to derive what I have now with respect to x, and we are done. So we'll go to the next page and do our partial with respect to x, and we are deriving x into spring the negative x into x squared plus y squared to the negative 1. And this just becomes a simple product derivative. So we have the negative x, which when we derive, it becomes negative 1. It will multiply x squared plus y squared to the negative 1. And then plus, now I have the negative x, and I'm deriving the bracket part. So when I derive that bracket, you should see we should drop the negative 1 and then have x squared plus y squared. Then now it's to the power of negative 2. But there's one thing that I'm missing at the end there, guys. What is it? I'm missing one thing. Anyone, you can give it a shot if you can see what I'm missing. Going down, all what we were doing was product rule. Anyone who can see what is missing? Something is missing, guys. And if we don't put it up, our answer will obviously be incorrect. What is it? Okay. In the interest of time, I'm going to give it to you. It is 2x. Where is the 2x coming from? The 2x is coming from your chain rule. Okay, so our final answer, put it up, which is our answer. Our answer is very simple. A second derivative with respect to z. Sorry, that will be x. So if you look carefully, it's negative 1 over x squared plus y squared. And then these negatives are going to multiply to be a positive. So we'll end up having 2x squared, I think. And then divided by x squared plus y squared all squared. And this is what we expected to get. You guys understand? A thumbs up if you do, a question if you don't. Okay, so that is our answer for that question, guys. Simplify your answer fully. So we can actually try and make a common denominator here. I think, yeah, we can. So let's maybe simplify it fully. So if I multiply by the common denominator, I'll have negative y squared and plus 2x squared, all divided by x squared plus y squared, all squared. So that our final answer will be, so those will add up and then we'll end up having x squared. So it will be x squared minus y squared divided by our x squared plus y squared all squared. So that is our partial derivative of x, of z, sorry, with respect to y, the x. So that is what our final answer will be. Any questions, guys? Please give me a thumbs up if you do understand, and ask a question if you don't. Okay, I see thumbs ups there. So that was about it. So there's 2 more questions left, actually. Let me see. There's this one. Yeah, I think let's ace it for calculus and then we will pause. Let me see, copy. Okay, here's the question. Right. Let's get to this one, guys. We have a curve in a plane defined by the parametric equations, x and y in this fashion, and we are required to find the second derivative at the point where alpha, or where that angle is pi over 3. What do you guys think we should do for this problem? Anyone who remembers how we work out such? These are parametric equations. Okay. Anyone, guys? Any volunteer? You can go ahead. Okay, so in the interest of time, what I'm going to do is to go ahead and work on this. So what you should see is that your x is a function of that, and also your y is a function of that. So it means that when we do our derivative, actually, we'll end up finding the derivative of x with respect to the dependent or the independent variable, which is that. And also when you do for y, you will find d like that. And then from here, guys, what is dy dx equal to? How do we get dy dx? Anyone?
I think it's dy over d theta over dx over d theta.
Yep, on point. So we just look at these, we'll have, it's the other way around, dy theta dx, and then our angle like that. So that is it. So which means when they are now talking about finding the second derivative, it means we derived twice. That is what it means. So this means what I need to do is find the second derivative of these. So I first need to go and find what is dx d theta. So let's go ahead. I'll need one of you guys to assist me. So look at the equations above and let's derive. So a is obviously a constant, so we can leave it out. When we derive cos, what you should remember is it will be negative sign. So I'll just do that. And then when you derive sine, you should see that you will use your chain rule actually there. So you'll have your thingy deriving sine will become cos. And then plus, now we derive our angle, and then we leave sine as is. So that is our first derivative. And if you observe carefully, it means this and that add up nicely. So let's go and simplify it. So our dx, d phi will be a into, I will have that, and then cos of the angle. Let me see if I didn't make any mistakes. Yeah, it looks like I did not. So we can now find the second derivative, guys. Remember, second derivative is the derivative of the derivative. So we just go and derive the derivative. So which is a into cos of that, of which the answer is going to be, cos will be negative, so it will be negative a sine, like that. So we are done with that. Now we need to go and deal with y. dy. If anyone, guys, wants to lead us, how do we find this one? It is going to be equal to what? Any volunteer?
So
Mm-hmm.
I have a question. So with what you just derived, why did you leave out the angle before cos of the angle?
Let's see. Yes, there was an angle. So that would have bent me in the exam. So cos of that. So it means I need to do my product rule here. But let me just take it to the next page. So thanks for that. These guys, have a look at my working. You know, at times I make very silly mistakes. Mistakes that will cost you in the exam. So look at my working and stop me. So if we do that, you will see that we need chain rule here. Not chain rule, but product, sorry. So we'll have 1 times cos. And then plus, we have our angle. And then when we derive cos, you should remember we'll get negative sign. Like that, close the bracket. So which means our answer, which is our second derivative of x, that just becomes a into cos minus our angle sine of the angle. Thanks for that. Now let's go ahead and work on our y, guys. So our dy will be equal to, I'll work it in the interest of time. We'll have a into, when you derive sine, you should know by now you get cos. And then minus alpha, I'm going to do my product rule. Derive the cos, we get negative sine. And then minus 1, I'm deriving that angle, and then I have cos of the same angle. Okay. So this means our dy phi will be equal to a into, so the cos's seem to be cancelling. So that cos and this one will cancel. We'll be left with negative that times sine of this. So we now need to do the second derivative. Y of which you will see that we will start by deriving the angle, which will give us -1, and then sine. Then we leave the angle as is. Then we derive sine, which gives us cos. And our second is therefore equal to a into, we have negative sine, the angle, then minus the angle, cos of the angle. That is what we have. Okay. Any questions, guys? So next we can just find the ratio and then substitute our angle there. So what we are lastly looking for is our dy squared, d squared y, and then dx squared, of which if you look carefully, my handwriting is becoming terrible here. So if you look at the division between the two, what you should have is a into negative sine minus our angle cos of our angle. And this should be divided by this one, what we got here for the second derivative of x, which is a into cos our angle minus sine of our angle. And we'll go and evaluate this at an angle of pi over 3. So let's go. So we'll go and take this and put in pi over 3 and see what we obtain. But there's one thing that will cancel. So we'll just go and focus on this portion here and sub in our angle. So our angle is pi over 3. Right, let's go. So are you guys allowed to use calculators? Just remind me. Okay, that is what we get. My question still stands. Are you guys allowed to use calculators? Let me delete that. Okay, so let me quickly do this. I'm not seeing any response. So yeah, when I was doing maths, or at least at maths, for whatever reason, they don't allow us to use calculators. And I think 1, 2, square root 3. I think that's okay. So we only need cos of pi over 3, which that is going to be 1 over 2. 1, 2, square root 3, that's the biggest side. And then we need sine of pi over 3, which is going to be square root 3 over 2. Yeah, okay. So you can go, guys, and put in these values. So you'll see that we'll end up having negative square root 3 over 2, and then minus pi over 3 times 1 over 2, and then divided by cos of pi over 3 is 1 over 2, and then minus pi over 3 times sine square root 3 over 2. So this is about what we have, and you could easily multiply by 6 to get this to be a bit simpler. I think And when you multiply by 6, you'll have a 3. You'll have 3 square root 3. And then minus pi divided by, let me see, times 6, that will be 3. And then minus square root 3 times pi. So that is what we end up getting as our answer. Do you guys understand? A question if you do, and sorry, a thumbs up if you do, a question if you don't. Okay. So that is about what you guys were, at least the group, previous group, what they were expected to understand from their exam. Do you guys have any question regarding these calculus questions? Let me see if we actually finished all of them. Just give me a second. So question 1, 2, 3, 4. And then there's one partial differentiation one. There's a couple of integration ones, okay? Right. Do you guys have any? I see a question from Yamuetwi. Yeah.
Can you please do that on the previous slide?
You want me to go back?
It is.
Mm-hmm.
What's my network?
Can you
so it's
see?
like, well, so I wanted to ask about the first derivative of dy over du what? Like,
Mhm.
is it supposed to be a positive starting?
Is it not supposed to be?
Isn't it supposed to be positive? And
Is A not supposed to be positive?
sorry,
Yeah, I'm struggling to hear you. You repeat that.
I'm saying the answer for sine the derivative of y, dy over du what? It is what?
Mm. So when we derive sine, are you asking, is it not supposed to be positive?
I'm struggling to hear you, but
Yeah. Do we have anyone in the meeting who understands their question? If yes, please just, you can ask on their behalf.
okay. Oh.
Yeah, your network is a problem. I think maybe try typing in the group or sending a VN and someone will ask on your behalf. Okay. Anyone else who has a question, guys? So where I'm going to stop is on these two questions, okay? So if you look at your 2024 paper, they still expect you to, or you were given one of these questions where we needed to integrate, and this was using substitution. And then we need to use integration by parts. So for this one, guys, it's a very interesting question. So what we know is that when we are dealing with angles, we are actually not used to integrating angles that have square roots. So what do you guys think is the best substitution here? So because we can clearly see that we have no problem integrating sine. The issue is the square root. That is where our problem is. So what substitution should we make? So the problem is the square root there. Anyone? The square root was not there, this problem would be done already. So what substitution can we make, or should we make? Anyone, guys? What substitution should we make there? Okay, maybe what we should do is let's try a substitution that just makes intuitive sense at first glance, and we'll see if we made a mistake. So we'll try setting u to be square root of t. And as you know, you need to go and derive u with respect to t. And remember that the square root here is the same as t to the power of a half. So when you derive, you end up getting 2 to the negative 1 over 2, which will be 1 over 2 times 1 over square root of t. So meaning when we do our du, this is what we get. So our du becomes 1 over 2 square root of t, 1 over t. And then dt like that. And what we usually try to do, if you remember, guys, we try to solve for dt and write it in terms of du. So if you observe carefully, your dt will therefore be equal to 2 times the square root of t and then multiplied by du. So meaning when we go to our equation, wherever we are dt, we are going to replace it by 2 times square root of t du. But square root of t, we already know it is u. So which means wherever we see dt, we are going to put 2 times u du. And wherever we're seeing square root of t, we are going to put u. So our integral changes now. It becomes the integral of, we now have sine of u. And wherever there was dt, we now put in this, comes 2u du. So which means what we are integrating now is very simple. We put in the 2 outside, we have u, sine of u du. That is the new problem now. 2 integral of u, sine of u du. And this requires integration by parts. There's no question about that. So let's go ahead and put up our expression for integration by parts. And our expression for integration by parts is very simple. We have u dv equaling u times v minus u dv. Sorry, that is not true. So this is minus v du. And remember, when doing integration by parts, guys, you need to choose u. You need to choose u and dv. You don't choose u and v. Some of you make that mistake. So what we usually choose as our u in such a situation is a polynomial. So our polynomial here is u. And what we'll choose as our dv is the other function. And the other function here happens to be sine of u. So it means that we have u equals u. I'll put this in quotes, and we have dv equals sine of u. So we require du. So when we derive that u, we get 1. And when we integrate the v, we end up getting negative cos of u, because we need v as part of our equation. So we can now go and plug back. So which means 2 times our u sine of u, du will be equal to u times v, which is u, multiplied by negative cos. So it will be negative u cos of u. And then minus the integral of, if you observe carefully, v, which is minus cos, we'll have minus cos of u multiplied by du, which is 1, and then du. So this should all be multiplied by 2. So the 2 is the common multiple here. So putting a 2, the 2. So this will end up being 2 into, you look carefully, negative u cos of u. And then outside there, we'll have negative, negative. So we'll end up getting a positive when we are integrating cos of u du. So when we try and simplify this, we'll have negative 2u cos of u. And then plus, when we integrate cos, you should see that we get sine, because you derive sine to get cos. To get 2 sine of u, and then plus c. So now we can sub back our u, because our original expression never had any u. So remember that we took u, insert it, and put it in space of square root of x. So therefore, as our answer, what we get as the integral of sine of square root of t dt is equal to negative 2 square root of t, and then cos of square root of t, and then plus 2 sine. Let's create some space. Sine of square root t, and then plus c. So that is what we get as our final answer. Do you guys understand? Thumbs up if you do, and a question if you don't. Okay. So that is how they were expecting us to go and solve this problem. Okay. And there's another one. And let's have a look. So let's crop to this one. And what I'm going to do is, you guys need to have something to do. I'm going to leave this one as homework. So you can share it among yourself, the groups, and work on it and see if you can find the answer. So you can take a screenshot and then send it in the group. Tell the others this will be the homework. I'll do one more calculus problem, which is very interesting. And that is, I'll push it up on my screen now. So for this one, guys, take it as a screenshot and then share it in the group. And tell the other guys this is going to be the homework. Yeah, so let's go to the next one that I want to close this with, which is this question. Okay, let's have a look at this one, guys. And this has to do with trigonometric substitution, which you are expected to be familiar with, but I'll help you to recap some of these concepts. So they tell us very straight, while starting, we should use trigonometric substitution to get this done. And with the trigonometric substitution, guys, I need you to remember a couple of things. And I'll just say here, remember, I need you to remember the following. If we have x squared minus a squared minus x squared. When we do our trigonometric substitution, do you remember, guys, what we substitute on x for this one? So for this case, or for a case like this, guys, what we are going to do is we are going to use sine. So we are going to do a substitution of x equals a sine theta. So whenever we see such. So once you see such a case, what you do is you substitute wherever you see x, a sine theta. Okay. That is one of the substitutions. And then when we find ourselves with the case where we see, let's say, a squared plus x squared, do we have anyone who remembers what is supposed to be our substitution? X is supposed to be a tan theta. Okay, let's go for the next one. And the next one is when we have x squared minus a squared. So once you see something like this, your x should be substituted with a sec of theta. This is what you need to understand when they speak about trigonometric substitution. And in the absence of understanding this problem becomes very difficult. So what we have here is a summary of trig substitutions. Okay, now with this problem, let's go and have a look at what is happening. So we can see that our substitution will actually happen because of the denominator. So I'm going to focus on that denominator because I want that denominator to take the form of either a squared minus x squared. And currently it is not. So I have 5 minus 4x minus x squared. So I'm going to try and rewrite this such that I'm easily able to do our substitution. So here's how I'm going to do that. I'm going to first write this as follows because I'm more comfortable dealing with this way. Then afterwards, if you remember, guys, there's something you did back in high school which was called completing the square. And that is exactly what I'm going to do with this problem. So I'm going to pull out a negative. After that, we have x squared becomes plus 4x minus 5. And what I do from here is just completing the square. So I have negative 1, and I'm going to have x plus 2 all squared, and then minus 5 minus 2 squared. Many of you should know this by now. And this will be negative 1 into x plus 2 all squared minus, this will be 9. And if you multiply this out, you will see that you will end up having 9 minus x plus 2 all squared. And this 9 here can be written as 3 squared minus x plus 2 all squared. And what I see above makes me very happy because it looks like the form that I need. So I urge you to make sure that you do revise your substitution. Now it looks the form of a squared minus x squared, and that makes me very happy. So which means when we look at our integral, what we have is the integral of x plus 3 divided by the square root of 5 minus 4x minus x squared, like this. So that makes me very happy because I know that this I can eventually, what you call it, make to have this form, and then I can do my substitution. But before we do that, there's two things we need to take care of. We need to make sure that we only have a constant on the numerator. So that is the catch. We need to make sure that we have a constant there. But there's something that you guys should remember, which has to do with substitution. If I derive what is down here, you think about it carefully, I'll end up getting negative 2x minus 4. So meaning on the numerator, I need to try and get 2x plus 4 or minus 4 for me to remove that x there. What do I mean? Let's go and do it. So what I mean is that I'm going to introduce 2x plus 6. I only need 2x plus 4, remember, because of that. So because I'm introducing this, it means I need to pull out a 2 so that this expression does not change fundamentally. So that I have 5 minus 4x minus x squared dx. Nothing has changed here. And then next, I can split my expression. I can have my 1 over 2 integral of, now I can have my 2x, what you would call plus 4, then divided by my square root of that there, 5 minus 4x, then minus x squared dx, and then I can deal with the other part, which is the 2, half of the integral of 2. The part that has a constant, I can already change the denominator to be what I just had found now, which is just the square root of 3 squared minus x plus 2 all squared. And that should have a dx. So that is what we have. And now I'm in a position to go and deal with the integration here. Okay, because all what this becomes is this becomes more like u. Okay, so if you remember, if you have 1 over u, what I'm going to do is, because I need these to be negative, guys, I'm going to pull out, and this is a very smart but very weird way of doing things. I'm going to pull this and make a minus here. And then my problem is as good as done, because it means now what I'm integrating is just 1 over the square root of u. So the first part, when I do the integration, it will just be 5 minus 4x minus x squared. I will just, what you would call add the 1, which will make it to be 1 over 2. And then I just need to divide by 1 over 2. And then the other part, I need to go and do my substitution for this one, which I'm going to deal with on the next page. So it's very important that, guys, as part of your preparation, you need to make sure, do you understand substitution? Do you understand trigonometric substitution? You use substitution, direct and indirect substitution. So let's go to the next page. And the first part just becomes, when those halves divide, it just becomes your -1 into the square root of all of that. 5 minus 4 x minus x squared. Now what I'm interested in is dealing with this portion here, of which the 2's will just cancel. So the integral I need to deal with is 1 over square root of 3 squared x plus 2 all squared dx. So let's go and focus on this integral and use our trig substitution as I showed you. Look at what I indicated to you. So if you look carefully, our case is this one. a squared minus x squared, meaning we are going to use sine as our substitution. So maybe let me take this to the next page. Okay, so if you observe that, you should be able to see that our x plus 2 should be equal to whatever the a is, which means 3 sine of theta. So remember, we are trying to change variables here. So our x will be 3 sine of theta minus 2. Then now we just find dx d theta. And this becomes 3 cos of theta. So meaning if you just take this to the other side, your dx will end up being 3 cos of theta d theta. So this means wherever we see x, we'll replace it with 3 cos of theta d theta. That is our substitution. So let's go. We'll have 1 over the square root of 3 squared, which is 9, minus wherever we see x plus 2, we put in 3 sine of theta, we square that, multiplied by 3 cos of theta d theta. So if you observe carefully, we'll have the integral of 9 minus 9 sine squared theta, then 3 cos theta d theta. And if you look at that denominator, guys, some high school stuff. 9 minus 9 sine squared. If you pull out the 9, you are left with 1 minus sine squared, which becomes a cos squared. So which means you have 3 cos of theta divided by the square root of 9 cos squared theta d theta, of which if you look carefully, you'll have 3 cos of theta. And once that divides inside there, it becomes 3 cos theta also, and then d theta. So these cancel out nicely. And what we are integrating is just d theta, which will end up being theta plus c. But remember that we don't know what theta is. Our answer was given in terms of x, so we need to try and revert back. But remember that what we did is we said x plus 3 equals, x plus 2 equals 3 sine of theta. So this means that our sine theta is the same as 3, as x plus 2 divided by 3, which therefore means that our theta is just the inverse sine of x plus 2 divided by 3. So that means that portion there, I just need to go and replace it with that. So our answer, finally, will be as follows. So for the first part of our equation, we have found that that is going to be negative square root of 5 minus 4x minus x squared. The second part, we just found now that it will be the inverse sine of x plus 2 over 3. And then very importantly, we shouldn't forget c plus c. Right, this was very interesting. You guys need to make sure that your substitution is on point headed to these exams. You guys understand? A thumbs up if you do, and a question if you don't. Right, I'm happy some of you do understand. Some of you, I don't see your thumbs ups, and neither do I see your questions. So yeah, that is about it, guys. I think this session was aimed at giving you a very good overview of concepts that you need to go and revise in preparation of your exam. So looking at your questions, we have done most of your calculus questions. an exception of very, I think, 3 easy questions left, which I'm going to leave for you as homework. There's no further question, guys. I think we can pause here. Don't forget to work on this problem. Any questions before we close? Are you guys happy? A thumbs up if you are. And you can unmute if you are not happy. I want to hear why, so that we can better the experience for you. Right? Awesome, guys. Cheers. I think let's pause here and enjoy the rest of your evening. Bye.